Hello everyone and welcome back to the channel. So what we're doing today is basically there's this chapter of momentum which is also part of IGCSE as well as O-level physics. So what I've done is because there's not a lot of practice material for the O-level students here, I've gone into IGCSE and I've found out questions relevant to us as O-level students. I've also gone through other sources like O-levels past papers and other sample papers and whatnot, to try to come up with some questions for us to practice. Now, needless to say, if I'm doing this, you guys know my style. This means that all of these questions that we are about to do now, I've thought about beforehand, and all of these are relevant to you guys. So let's start with these questions, just so we can get good at this chapter. Alright, question number 1. An object of mass 2.5 kg is acted upon by a force of 8 Newton. The object has an initial speed of 3 meters per second. After time t, the speed of the object increases to 3 meters per second. For which time does the force act? So we know that the definition of force is this rate of change of momentum. And similarly, I can also rearrange this and say that the time for which the force acts, which is t here, that's the change of momentum divided by force. So for the change of momentum, I just saw that the mass of the object was 2.5 kg. This is its final speed, this is its initial speed, so I can use mv minus mu for the numerator. So mass is 2.5. Again, I can also factor out the mass is common. So 2.5 times v minus u divided by the force, which is 8 newtons, gives me my answer, which would be 1.25, or correct to 2SF, that's 1.3. Let's have a look at question number 2. Two railway wagons are on the same straight horizontal track. One wagon is moving with initial velocity u, other wagon is stationary. Moving wagon collides with the stationary wagon. The two wagons connect to each other. So this is basically the example of a sticky collision, and move with a velocity of 5.8 meters per second. After, what is the initial velocity of the moving wagon before they collide? So this is basically conservation of momentum. I would say total momentum before should equal total momentum after the collision. Total momentum before is just the momentum of this object because this is stationary. So I would say that's 8,000 times u equals total momentum after. So for this combined object, I obviously know that the mass of this is going to be the sum of the masses of these. So 8,000 plus 12,000, that's 20,000 times 5.8. And then I just need to rearrange this equation to find u. So u turns out to be 14.5 meters per second. Let's go on to question number 3. A body undergoes a change of momentum. What is the unit for change of momentum? So you should know these two units for momentum, and obviously these would also apply for changes in momentum: kg meters per second or Newton second. So Newton second, this is C. Easy. Question number 4. A ball of mass 0.16 kg is moving forwards at its speed of 0.5 meters per second. Second ball of mass 0.1 kg is stationary. The first ball strikes the second ball moves forward at a speed of 0.5. What is the speed of the first ball after collision? Now again, if you feel like this is a lot to unpack, just make a small diagram to make your life easier. That's what I'm going to do. So let's say this is the first ball. This is mass 0.16 kg, which is moving at speed 0.5 meters per second towards this second ball, which is initially stationary. And then the collision happens. So let's say this represents the collision. After the collision, we need to find the speed of this first ball. Let's say this is v, and the speed of the second ball after collision. This is what? 0.5 meters per second. Right, and the mass of this purple ball is 0.1 kg. So again, just conservation of momentum. I am trying to make you guys have this habit, because in paper 2 there is marks for this. Always start with this: total momentum before collision equals total momentum after. total momentum before is just 0.16 times 0.5. Because there is no obvious change in direction, that is why I'm not using the sign convention here. If, for example, this was to the left, then you would have to use the sign convention. Total momentum after is 0.16, the object in this pink color, 0.16 v, plus total momentum after, which is 0.1 times 0.5. Here on out, this is just math. So we just rearrange the equation and find v, which turns out to be 0.1875 or 0.19 meters per second, correct to SF. Okay, question number 5. A constant force acts on a body causing the momentum of the body to increase. Which expression relates the force to the momentum and the time taken? We know force is rate of change of momentum. This is the definition. That's also you would write in a paper 2 question if the examiner says define momentum. Rate of change of momentum. So this looks like the first one. Change in momentum over time taken, not just momentum over time taken. It's a change in momentum divided by the time in which that change in momentum occurs. Question number 6. Alright, question number 6. An air pistol fires a pellet forwards. What is the motion of the air pistol? So again, if we just make a small diagram like this, pretty ugly pistol, but whatever. And this fires a pistol, a pellet forwards. So the pellet has motion forwards. So we know that the gun is going to recoil, it's going to move back. This is basically because of conservation of momentum. Because if total momentum before was 0, then by conservation of momentum, total momentum afterwards must also be 0. So whatever is the momentum of the pellet to the right should equal the momentum of the pistol towards the left, so that they cancel out and so that the momentum afterwards is also 0. Now obviously if I'm talking about mv, mass times velocity, which is momentum, because of the pellet I know that because it has a really small mass as compared to the pistol, it's going to have a higher velocity. So when we talk about the pistol, because it has a larger mass, it would recoil, but its velocity would not be as large as this, the velocity of the pellet. So the air pistol would move back with speed less than the pellet. So this is B. Next question. An object of mass 0.8 kg is moving in a straight line at a velocity of 2 meters per second. Force is exerted on the object in the direction of motion for a period of 1 minute. It's not an SI unit, so this is 60 seconds. And the velocity of the object increases to 6. What is the force exerted on the object? Again, we can just use the definition of force. Force is rate of change of momentum, which is mv minus mu over the time taken. Again, I can factor out m as common, 0.8, v minus u, final velocity is 6, initial velocity was 2, divided by the time, which is 60 seconds, and this gives me the force, which is 0.053 newtons. Next, question number 8. A gas molecule strikes the wall of a container. The molecule rebounds with the same speed. So the gas molecule hits, rebounds, and it has the same speed. So if this speed is v, this speed is also v. What happens to the kinetic energy and what happens to the momentum of the molecule? So because the speed stays the same, the kinetic energy is also the same, and the magnitude of momentum would be the same as well. But because momentum is a vector quantity and direction does make a difference, what we'll use here is basically the sign convention. So right is positive, left is negative. So initial momentum would be plus mv and the final momentum would be negative mv. Right? So momentum does change. So this is C. Again, momentum as a chapter is all about alertness of mind and knowing when and where to use the sign convention. Question number 9. A resultant force of 500 Newton acts for 10 seconds on a car of mass 1000 kg. This causes the velocity of the car to double. What is the final velocity of the car? So again, force as the rate of change of momentum. Let's say initially it had some speed v and then it became 2v, right? Because it doubles. So I would say the mass, which is 1000, mv minus mu is what I'm using, 2v minus v over the time, which is 10, and this equals to 500. So your 2v minus v is basically v, which is 5 meters per second. But keep in mind, what you took it as v is the initial velocity. What they're talking about is the final velocity, which you took as 2v. So 2 times that is going to be 10 meters per second, right? Because I took my initial velocity as v, not as 2v, so that's not my final answer. Next, at time t equals to 0, a cannonball is stationary inside a cannon. The cannonball is then fired from the cannon at time t equals to t. The cannonball moves forward, cannon moves backwards. Again, this is because of recoil, and this is because of the conservation of momentum. Because total momentum before must be 0, total momentum afterwards must also be 0. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between time t equals to 0 and t equals to t? Total momentum never changes, so this is the same. And initially there was no kinetic energy, but afterwards the cannonball and the cannon both move, so they do have kinetic energy. So overall it has changed, so this is B. Alright, the total momentum always remains the same. Question number 11. An object of mass 50 kg accelerates from 2 to 10 in the same direction. What is the impulse provided? Impulse means this symbol, which is basically the change in momentum, which is F delta t. But if I look here, I don't have F or delta t. So I'm just going to use this idea that it's the change in momentum. So I can factor out M is common, 50. And V minus U is 10 minus 2, so 50 times 8, which is 400 Newton second. A bullet of mass 0.1 kg travels horizontally at a speed of 600 meters per second, striking a stationary wooden block of mass 1.9 kg resting on a frictionless surface. Bullet stays in the block. What is the speed of the block and what is the speed of the bullet and the block immediately after impact? So again, you might have guessed, this is an example of a sticky collision where two objects become one after the collision because the bullet becomes embedded in the block. So if I use conservation of momentum, again, total momentum before should equal total momentum after. Initially the momentum is just of the bullet, which is mass of this much, speed of this much. Afterwards, and again, before obviously the block is stationary, so it doesn't have any momentum. Afterwards, they both become one object, so their masses get added up. So this is 2 times this V that I need to find out. Again, now I just need to cross multiply and solve. So this turns out to be 30 meters per second. Which expression gives the momentum of an object? So momentum is by definition mass times velocity. This is weight, this is kinetic energy, this is resultant force. Again, another question related to sticky collisions. A car of mass 1000 kg traveling at 8 meters per second collides with a lorry of mass 3000 kg that is traveling at 2 meters per second in the same direction. After colliding, the two vehicles stick together. What is the speed after the collision? So again, I have total momentum before equals total momentum after. Before, it's 1000 times 8. Again, no need to use sign convention because of this phrase right here. So 1000 times 8 plus 3000 times 2. They stick together, so their masses get added up. So that's 4000, and you need to find the speed of the combined object. Once you become really good at this, then you don't need to draw the diagrams anymore. But initially, I would highly recommend all of you to draw these. Solving for V, this turns out to be 3.5 meters per second. Question number 15. A visitor to a fairground throws a soft object of mass 0.12 kg at a coconut of mass 0.48 kg. The soft object stops moving when it hits the coconut. So initially it had some momentum, but afterwards it will not have momentum because it stops moving. In order to dislodge the coconut, it must be made to move at 0.1 meters per second. right? So the coconut must be made to move at 0.1 meters per second. What is the minimum speed with which the visitor should throw the soft object in order to dislodge the coconut? Now, because this is a lot of information to unpack, I'm just going to make a small diagram here and just show this. This is my soft object which is to be thrown, and this is basically the velocity I need to find at this coconut which has a mass of 0.48, and then the collision happens and the coconut must be made to move at 0.1 meters per second, and afterwards my soft object comes to rest, right? So this comes to rest. Now I need to find this speed. So this is just conservation of momentum. And once you figure what this question really says, the math is really simple here. Again, total momentum before equals total momentum after. Initially this was at rest, the coconut, and afterwards the soft object is at rest. So you will just say the mass of the soft object, which is 0.12 times v, equals to the mass, the momentum of the coconut, which is 0.48 times 0.1. And again, now you just solve. So using this, my velocity turns out to be 0.4 meters per second. All right, next. Now this is a question which is slightly different from the ones we've been doing right now. A ball of mass 0.5 kg falls, hits the floor at 10 meters per second, rebounds at 8 meters per second. The time in contact with the floor is given, and you need to find the force acting on the ball during the collision. Now, why this is different is because you can obviously see there's a change in direction. So you must now use the sign convention. By default, you'll always see me using this: upwards positive, downwards negative, in keeping with the y-axis. Similarly, right is positive, left is negative, in keeping with the x-axis. Now I use this. Force is the rate of change of momentum, and momentum, the change in it, is mv minus mu over delta t. Just to show this to you once, right now I am intentionally not factoring out the ms common, because it's very easy to make minus signs with it's very easy to make mistakes in the minus sign with this. So mass is 0.5, final velocity is 8 upwards, so this is positive 8 minus 0.5, and the initial velocity is 10 downwards, so that's negative 10 divided by the time, which is 0.5 seconds, right? So when you find this out, this is going to be 18, and now you see two options in the answers, which is 18 upwards and 18 downwards. You can just make use of your sign convention to understand the direction of the force. Now because this is positive, this means in keeping with your sign convention, this force is upwards, so it's 18 Newton upwards. Let's go on to the next one. Question number 17. Object of mass 4 kg is moving with a velocity of 3 meters per second. What is the momentum? Very straightforward, just multiplying the two by using P equals to mv. 18. How is momentum calculated in terms of the mass and velocity, and what type of a quantity is P? It's P equals to mv, and it's a vector quantity. Again, very straightforward. An object of mass 1.2 kg is moving with the velocity of 2 meters per second. When it is acted on by a force of 4 newtons, velocity of the object increases to 5. For what period of time does the force act? Again, we've done questions like these just moments ago. So force is the rate of change of momentum. So time would be the change in momentum over force. So change in momentum would be mv minus mu. So 1.2 v 5 u 2 force 4. And this gives us the time as 0.9 seconds. An object is moving at 3 meters per second, force acts. After a time, the object is moving at -4. Mass of the object is given. What is the change in momentum? Again, you just need to be like really precise about what you call your final, what you call your initial. Now, once you do this question, now you can see why, how easy it is to factor out this, because in this one, the positive and negatives are given already. However, when questions are given related to diagrams, then you have to see for yourself what's going to be positive, what's going to be negative. Once you get really good at that, then you can factor out the m as common, and then you can do it all at once. So final velocity here is afterwards, after the action of the force, which is -4, minus the initial velocity, which is +3. So this is basically just 3. So this is -4 minus 3, which is -7, times 5 is -35 kg meters per second. Now, for example, now if you remember what you just did in the previous question, you can do this one very easily. A ball falls vertically to the floor, rebounds vertically upwards. Again, because it's your first time, let's make a diagram. Just before it hits the floor, its speed is 4, and afterwards it rebounds and it has speed 3. Mass of the ball is given. What is the change in momentum? Again, upwards, positive, downwards, negative. Using force is the rate of change of momentum. So mv minus mu over delta t. So mass times final velocity, so 0.5. Final velocity, now I'll factor this out as common. Final velocity is 3 upwards, so this is +3, minus the initial velocity, which is 4 downwards, so this is -4. Alright, this is what I was talking about. Some people, they confuse these two minus signs. This minus sign, the first one is just basically because of the change. The second minus sign, which is inside the bracket, is because of the sign convention, right? Divided by the time. Okay, so we don't have to find force here. We just need to find the force. We just need to find the change in momentum, right? So this is all we have. So yeah, we just need to do this. So 3 minus -4 is 7 times 0.5 is 3.5. This is positive 3.5, and positive means upwards. All right, let's go on. Question 22. A ball has a mass of 2 kg, approaches at the speed of 3 meters per second, rebounds at 1 meter per second. What is the impulse? Again, impulse is just the change in momentum. And the diagram also shows you this, that you have to use the sign convention. Again, right is positive, left is negative. Change in momentum is mv minus mu. So factoring out the m as common, that's 2 kg. V is the final velocity, which is 1 to the right. So this is positive. So this is +1 minus u, which is 3 to the left. So this is negative. So -3. So this is going to be 1 plus 3, which is 4 times 2 is 8. So that's C. Oh, actually, the units are wrong because you have this in 2 options, right? So the correct answer hence is D. All right, let's go on. A tennis ball has a mass of 57 grams. Again, in non-SI unit, this should be immediately apparent to you that this would be 0.057 kg. Tennis player hits the ball with a tennis racket. The tennis ball has a velocity of 25 meters per second when it hits the racket. Velocity of the tennis ball when it leaves the player's racket is 15 meters per second in the opposite direction from its approaching direction. Again, opposite directions means you need to use the sign convention. Average force exerted is 35. For how long is the tennis ball in contact with the racket? Again, if you feel like you need to make a diagram, and initially this ball is coming in and it has a speed of 25 meters per second like this. When it leaves, it has a speed of 15 meters per second, and you need to find the time. So since force is rate of change of momentum, the time would be the change in momentum over force. So change in momentum is mv minus mu. Mass is given 0.057. Again, sign convention, obviously, right positive, left negative. So your V is 15 to the right, so this is positive. So plus 15 minus the initial velocity, which is 25 to the left. So this is -25 divided by the force, which is 35 newtons. So you just plug all of this into your calculator. The answer that we get is C. Moving on. Question number 24. Object X moves to the right along a frictionless surface towards a stationary object Y as shown. They make a noise as they collide and then both objects move to the right. Which equation is correct? Now because they make a noise, this means some energy is lost. So definitely if I look at the options, then kinetic energies will not be equal because some of the energy is lost as sound. Change in momentum of X equals change in momentum of Y. Now this we don't know how to work with because we don't have any values or anything here. So I'm kind of confused about this. But if I look at option 2, that's basically the same because impulse is change in momentum. So if both of these are saying the same thing, then I know these cannot be correct because they're basically the same thing and there can only be one correct option, which by default must be D, which is basically the conservation of momentum. So total momentum before is the momentum of X should equal the momentum of X and Y after the collision. This is correct. Now what does option A and B, what do they really mean? And what would have been the correct option? Now basically the idea is this, that the conservation of momentum actually follows from Newton's third law, which is that both of these apply equal and opposite forces on each other. So when they collide, X will apply a force on Y, and I know Y will apply an equal and opposite force on X. If I write it like this, I would say Fxy equals Fyx, but because they have opposite directions, I'll just put a negative sign here. Now if I think about force as the rate of change of momentum, then what I would say here is this, that this is the force that X applies on Y. As a result, the momentum of Y would change. So I would say the change in momentum of Y divided by some time, the time in contact, would be equal to the rate of change of momentum of X divided by the time in contact, and there's the negative sign from above. Now I know that when both of these will be in contact, obviously they will be in contact for the same time, so these times cancel out. So what should have been correct, or what would have been correct, is if the change in momentum of X is equal and opposite to the change in momentum of Y. So only if either of these options had a negative sign here, these would have been correct. But as it stands, they're not correct. 25. Three situations are listed. An object has a resultant force acting. A moving object experiences an impulse. An object is decelerating. In which situations is the momentum of the object changing? If a resultant force acts, by definition there will be a rate of change of momentum, so it would change. Impulse, it's just called the change in momentum, so the momentum would also change in this situation. And when the object is decelerating, again there would be a change in momentum. So all of these have changes in momentum. Alright, question 26. A ball of mass 0.16 kg is moving forwards at a speed of 0.5 meters per second. Second ball of mass 0.1 kg is stationary. First ball strikes the second ball moves forward at a speed of 0.5. What is the speed of the first ball after the collision? So 0.16 times 0.5, I think this is a repeated question. And the second one is stationary. Second ball is then moves forward at 0.5. So second ball has a mass of 0.1 times 0.5, and you need to find the mass of the first ball, 0.16 V. So V turns out to be 0.1875, just 0.19. Which statement describes the impulse acting on an object? Impulse is the change in momentum. Boom. Next. Which expression for impulse is correct? There are really two. Delta P is F delta T, and the other one is just change in momentum. So mv minus mu, not this, and it's this. Constant frictional force acts on an object moving for a short amount of time, causing the momentum of the object to decrease. Which expression is used to calculate time for which the force acts? We've been using this quite a lot, even in this time that we've been doing this worksheet. So just rearranging. So it would be change in momentum over force. That's A. Two cars P and Q have different masses and different speeds as shown. Which row correctly compares the momentum and the kinetic energy of P with the momentum and kinetic energy of Q? So 1000 times 10 is 10,000, 500 times 20 is also 10,000. So momentum is equal. Kinetic energy, so you can find this out. So this would be half into 1000 into 10 squared versus half into 500 into 20 square. I don't even need to do this calculation. I know for a fact this would have a greater momentum, a greater kinetic energy. And I'll also tell you the reason. Kinetic energy generally is given by half mv square. What's the difference between the two is that this has half the mass but twice the velocity. Now I can say that the kinetic energy is basically proportional to mv square. Now what this means is when the mass halves, the kinetic energy would also halve. This is basic direct proportion. But when the velocity doubles because of the square on top, this would also increase by a greater factor. This would basically quadruple, and the kinetic energy of Q would be greater. So the kinetic energy of P is less than Q, that's C. Alright, next. 31, girl of mass 50 kg runs at 6 meters per second. What is the momentum? Again, 50 times 6, 300, not joules, kg meter per second. Vehicle of mass 900 kg is traveling with velocity 20. So this would be 18,000. And that's going to be meters per second, kg meter per second as well. So that's 32C. 33. Again, we just did a question like this. Now you guys are very well versed at how to do this. Right is positive, left is negative. So MV minus MU 0.06. V is negative 40 minus U, which is 25, divided by the time, which is 50 milliseconds. So into 10 to the negative 3. And that turns out to be 78 newtons. Pretty similar question. It's just that this one is easier because it's just asks for the change of momentum. Final velocity negative 2 because it's to the left. Initial velocity positive 3. mv minus mu, so 0.3. v is negative 2. u is 3. So 0.3 times 5 is 1.5 to the left. That's what the negative sign shows. An object has a mass of 60 kg, decelerates from 50 to 20 when a resultant force of 300 Newton acts. For how long does the force act? A lot of people ask me this question, can we do this using F equals to ma? The answer is yes, you can do it and you would still get the same answer. Because we've been doing a lot using rate of change of momentum, let me just show you how you can reach the same answer using this as well. Resultant force is 300, mass is 60, acceleration is v minus u over t. So this would be 20 minus 50 over the time. Because this force is basically slowing it down, I would add a negative sign here because it would be acting opposite to the direction of movement for it to slow this object down. So I would just rearrange this equation. So 60 times negative 30 over negative 300, and I would get my answer for 35 as C. Resultant force of 4 Newton acts on an object of mass 0.5 kg for 3 seconds. What is the change in velocity caused by this force? Again, I'm now coming back to, what do you call it? I'm coming back to the usage of the momentum equations. So force is rate of change of momentum, mv minus u over t. If they're asking me for the change in velocity, that's basically this thing. So it would be ft over m. So ft, force times time over 0.5. So this would be 24 meters per second. On to the next question. An object of mass 3 kg traveling at a speed of 6 meters per second collides with an object of mass 2 kg traveling in the opposite direction at a speed of 2 meters per second. Objects stick. What is the speed and direction of the combined mass after the collision? Again, this is a slightly different question, but nonetheless, this would be done with the same approach. Total momentum before equals total momentum after. Again, sign convention, right is positive, left is negative. So total momentum before 3 times positive 6 plus 2 times negative 2. This would equal total momentum after the collision. After the collision, they stick. So it's a 5 kg object and has a velocity of v, right? Now just a general thing, whenever you want to double check your answers as well. So this one, as you can see, would be 3 times 6, which is 18. This is 2 times 2, which is 4. This is to the right, this is to the left. This is obviously greater. So I can say total momentum before the collision is towards the right because 18 is greater than 4. So total momentum after would also be to the right because it must be equal by the conservation of momentum. So it has to move towards the right. This is what I can gauge on my own. And my answer will also tell me this. 3 times 6 is 18, minus 4 is 14. So V is basically 14 over 5, which is 2.8. And the positive sign here is in keeping with my sign convention. So this is moving to the right. Next question. An electron is moving with a speed of 5 into 10 to the 5, 6. Okay, this is 6. Neutron is moving with this speed. Mass of the electron is this much. Mass of the neutron is this much. Which row is correct? Greater momentum. So momentum is mass times velocity. So this would be for the electron. This would be 5 into 10 to the 6 times m. So this is 5 into 10 to the 6 times m. No surprise there. For the neutron, it's 5 into 10 to the 4 times 2000 m. So this turns out to be 100 into 10 to the 6 m. Now which is greater? 10 to the 6 and m are common with both. So obviously the momentum of the neutron is greater, right? And if I try to do kinetic energy, so with kinetic energy, I would say that for the electron, can I move this? Okay, I can. So with the kinetic energy, what we just did is momentum. With kinetic energy, I would say half mv square. So half m, and v square is 5 into 10 to the 6 squared, right? So when I solve for this, 5 into 10 to the 6, squaring this, dividing by 2 is 1.25 into 10 to the 13 m. If I do the same for okay, why did I just write m? This is supposed to be p for momentum. So this is p here and here. Kinetic energy, half into 2000 m into 5 into 10 to the 4 squared. Some of you might already be guessing that because of this square, the kinetic energy of the electron would be greater, but still let's see. 5 into 10 to the 4 squared times 2000 divided by 2 is 2.5 into 10 to the 12 m. 10 to the 12 m. So which momentum is greater? Obviously this one. So this is the electron has the greater kinetic energy and the neutron has the greater momentum. 39. Two objects x and y move directly towards each other. Both have the same mass. So mass m, mass m. Object x has a velocity of 5 to the right, y has a velocity of 3 to the left. X and y collide and stick together. What is their velocity after colliding? Again, sign convention, obviously, right is positive, left is negative. So this would be total momentum before equals total momentum after. So this would be 5. All right, always write the mass first. So mass times plus 5 because it's to the left, plus mass times negative 3. Again, you guys might be thinking, and it's good that you are, because this is a greater momentum, so the combined object, because they stick, would also be moving to the right. So it's definitely not to the left. Equals total momentum after, so they stick, so their masses add up, equal to this. So this is 2m right? 5m minus 3m is 2m equals 2mv. So these cancel out, and this is 1 to the right. All right. Question number 40. A ball is at rest on the ground. A boy kicks the ball. The boy's boot is in contact with the ball for 0.04 seconds. Average force is given. Ball leaves the boy's foot with a speed of 20 meters per second. Which row gives the impulse of the boot on the ball and the average acceleration? So impulse is change in momentum, right? So F delta T for that, right? Because we don't have the mass of the ball, so we can't use mv minus mu. Force is 200, acts for a time of 0.04 seconds. So without calculation, it seems like it's definitely not going to be 5,000. It's definitely a small value. An average acceleration. So how can we find the acceleration? We know that it was initially at rest. This is the final speed, and this is the time. So I can use A equals V minus U over T. So 20 minus 0 over 0.04. And this turns out to be 500 meter per second square. So this is B. Just a last few questions left. Momentum of a body is changed by force acting on it for some time. Which action increases the change in momentum? What equation are we talking about here? We're talking about this equation, right? The equation for impulse. So which one would increase the change in momentum? Doubling the force and halving the time means you are doubling this and you are halving the time. This means it has no overall effect, so it's definitely not A. Doubling the force for the same time means this will increase the change in momentum. This is correct. Halving force, halving time would halve this, so the change in momentum would become a quarter of what it used to be. So it's not this, because we're looking for increases, and halving the force, doubling the time is pretty similar to this. So it's B. 42. A toy train of mass 0.5 kg is traveling along a straight track with a velocity of 3, collides with a stationary train of mass 1. Trains then stick together. What is the velocity of the combined trains? Again, total momentum before equals total momentum after. Total momentum before is of the 0.5 kg train, which was traveling at a velocity of 3. And afterwards, initially the other train was not traveling, the 1 kg train, and afterwards they stick, so the masses get added up, and this is what we have. So V turns out to be 1. And we know that if this was traveling in any direction, let's say it's to the right, so by conservation, my combined object must also travel in that same direction, because momentum is a vector quantity. So it's 1 meter per second in the original direction of P. Question number 43. An object with a mass of 0.2 kg moves at 0.2 meters per second as shown. Which other object has a momentum that is identical to the momentum of this object? Identical means not only is the magnitude the same, the direction must also be the same. So the only one which has the same direction is this. It must be this. And 0.2 times 0.2 is the same as 0.4 times 0.1. So you didn't even have to bother with the other three. Footballer kicks a stationary football. His foot is in contact for this much time. Mass of ball is this much. Initially it was stationary. The final speed is this much. You need to find the average force. So rate of change of momentum. So mv minus mu, 0.4. V is 25. There is no u here. And the time is 0.05 seconds. And the force turns out to be 200 newtons. 45. A ball of mass m falls vertically, hits a hard surface. Speed on hitting the surface is v1. The speed with which it rebounds is v2. What is the change in momentum? Again, the sign convention tells you how to do this. Upwards, positive, downwards, negative. So you would say this is v2m. So we are finding change in momentum. So v2, so your final velocity is positive v2 minus v1. So v2 plus v1, that's C. 46. What is the relationship between impulse acting on an object and change in momentum? So we know impulse is basically the change in momentum. A. 47. This is a good question because this is theoretically a very involved sort of question. A rocket is launched upwards from the surface of the moon. Hot gases are ejected downwards over a very short period of time. Which statement is not correct? So right now there is this rocket which is going up. Hot gases are ejected downwards. So these are the gases. So this is the momentum of the gas. And what will be asked in this question is some relation with the momentum of the rocket. Now the first one says the rocket experiences a downward force. I imagine a lot of the students who did this incorrectly would have circled this because of this gas being ejected, there would be an upward force, but does it experience a downward force anyway? The answer is yes. That's called the weight of the rocket. The rocket experiences an upward force. This is also correct. So it cannot be an answer. This is basically the thrust it receives which propels it upwards. Total momentum of hot gases is equal to the momentum of the rocket. Now this looks very tempting because we know by conservation of momentum, the momentum of the rocket and the momentum of the gas must be equal, because if the rocket is launched upwards first, there is no total momentum before, right? So if I write this out, total momentum before equals total momentum after. So I would say that the total momentum before is 0, and I would say the momentum of the rocket plus the momentum of the gas would be equal to 0. So it might be tempting to say that the momentum of the rocket and the momentum of the gas should be equal. If there was just a slight rewording to this question, and if the question says the magnitude of the momentum of the hot gases is equal to the momentum of the rocket, right? So the magnitude of momentum of hot gases is equal to the magnitude of momentum of the rocket, this question would have been correct. But the problem here is this, that they are traveling in opposite directions. It is a vector quantity, direction does make a difference. So I would not say they are equal because the directions are different, right? As we did the question before as well. So the total momentum of the hot gases is opposite and equal to the momentum of the rocket. So as it stands, this is not correct. This is the answer. Why is this correct? Total momentum of hot gases and rocket when the hot gases have been ejected is 0 is because it's this equation, right? So this equation says that the total momentum before equals total momentum after, which is also shown here. You can also see this option C, why it's correct. I mean, why basically the statement is wrong in terms of this. This is how the equation would be. So momentum of rocket is equal and opposite to the momentum of the gases. Last question, question number 48. A cricket ball has a mass of 0.16 kg. Ball travels at 30 meters per second. Ball is hit by the bat with a force of 10,800 after being hit. The ball moves off at 30 meters per second in the opposite directions. Again, sign convention, right is positive, left is negative. So for finding the time of contact, again, it's the rate of change of momentum equation, but flipped, rearranged. So change in momentum would be mv minus mu. Mass is this much. V is to the left. So this is negative 30. So minus 30 minus plus 30, because that was to the right, divided by the force, which is 10,800. So using this, you can find the time in contact, which is 8.89 into 10 to the negative 4. So that's option B. Also, just a closing note for anybody who might be using my past papers, in that the option A is circled, that's wrong. C is the correct answer for this one. Alright, so I hope you guys had fun and that you guys learned how to actually tackle questions related to momentum. So in the next video, we'll be doing structured questions related to the same chapter. See you there.